Hello there, it's Jay here from Jay's Vintage Junk, and today we're going to have do a little bit of work on the Murphy A24 I've got here. Now, if you have seen the previous video on this radio, you know I actually picked this up out of a rubbish skip. It had literally been thrown in the rubbish. One problem with it is that one side of the cabinet is very badly damaged. The rest of the cabinet is actually really quite good. So what I'm basically going to do in this video, it's one of these radios that if the chassis is in good condition, if there's nothing majorly wrong with the chassis, I'll put the effort into restoring the cabinet. If there's something majorly wrong with the chassis, there's probably too much effort in actually getting this radio back into full working order. There is an awful lot of useful parts, you know, on this chassis, but I mean, I don't really like doing that if the radio is savable. So basically what I want to do in this video is just assess the chassis. One thing that is concerning me about it is and this is one of the reasons why I've not just tried powering this up, there is a lot of wax down here actually dripped off the chassis. Now that isn't necessarily mean that the transformer is bad. It has got some wax that's actually leaked out of it, but that doesn't necessarily mean that it's got a shorted turn or the transformer is bad. It could have just got very hot in the past. Bear in mind that that's the output valve there, that's the rectifier valve there, and those are basically the two valves that run hottest in the radio, and those are, as you know, basically as close to the mains transformer as you can get. It could just be this is a very high hours set. It could also be that we've got a bad capacitor, and this radio may have been used for some time with say a shorted capacitor on the HT line, which would be putting excess strain on the transformer. That could be the cause of it. And like I say, it doesn't necessarily mean that transformer is completely dead. Basically that's where we're going to start. I'm going to do some basic checks on the transformer and just make sure that the transformer you know, isn't completely open circuit or anything like that. And then what I think we'll try and do is we will power just the filaments up. We'll pull the rectifier out so we can't produce any HT, and we'll try powering the radio up and slowly bring it up on a variac until we've got like 230, 240 volts onto here, and we'll just let the transformer run for a while, monitor it, make sure it's not getting too hot, and then we'll move on from then. I don't know if we will do, but hopefully at the end of this video we'll actually see if we can actually get the chassis to play in one form or another. There's some capacitors in here which we're going to have to do something with really before I'm 100% happy actually firing this thing up, but we'll get to them when we get to them. First things first, let me get a meter and some leads out. Right, okay. Let's get some random leads out. Now I've just realised that I've put my camera leg in front of the drawer that I need to get my meters out, so you just have to bear with me a second. Aha. Well, in fact, there we go, that's better. I will get my, this is a micronmeter meter. I think the first test meter I ever bought when I was a kid, when I was about 8 or 9 I think, was a micronmeter very similar to this. It wasn't a clamshell one like this. This is super fancy being a clamshell one, but it was basically the same meter, just in a flat panel like that. And there's something about when you're working on, you know, old equipment like this to use an analog meter as well. It's not necessary, you can use a digital meter if you want, but there's just something about using an analog meter when you're doing stuff like this. Right. Let's get that onto the ohms range. See what that's like. That's okay, that's good. Right. First thing we'll try, let's just see if we've got continuity across the mains lead. So we go on there and we go on there. That could just be, yeah, that's my fingers. In fact, what we'll do, so we're not making that mistake, we plug that one in. And we've got a crock lead for one side. Clip on there like that, and then we can just hold it on the other side, and we're going to get got nothing there. Let's see if we can switch the radio on. So we don't seem to be getting anything across the mains wire in there. Which could mean that we've got an open primary on the mains transformer. So let us have a look. We'll go from there, because obviously the end of the wire there could be a break. We've got the switch in there, the switch could be dodgy. Let's basically go onto the primary of the actual transformer. Now that there and that there should be the primary wires. Get the meter in again. Yes, I'm pretty sure that's the primary there. Okay. Yeah, that's fine. That means that the primary on the transformer is indeed fine. That's one side of the tap-in there, and we're just going across the other tap-ins, which is that's the one we're using at the moment. 230, 240, 233 to 250 volts. If I go on there, I don't know if you can make it out on the meter, but we've got continuity basically across the primary there. We can go up on there a little bit, we should get a better. There we go. Yeah, that's fine. It should be unless. There we go. So we know that the primary on the transformer is an open circuit. That's the first thing we really wanted to check. In fact, that will be across our 6-volt secondary, I am guessing. The dial light there, so we can also do that test as well. We take the bulb out, otherwise we're just measuring across the bulb. And this is on the secondary side of the transformer. What we've just measured was on the primary side of the transformer. And we go across there. There we go. So yeah, or at least our 6-volt secondary seems okay. That bulb's a bit dodgy. I'll pull the rectifier out, and what we want to do is just check the filament winding for the rectifier, because basically on these old sets the rectifier is usually run because it's a directly heated cathode on the rectifier valve. Directly heated cathode or anode, I can't remember off the top of my head, but one of the main elements of the valve is directly heated. It's tied with the heaters, which means you have to have a separate tapping on the transformer for the rectifier's heater. Obviously it's usually 5 volts on these older sets, these mid 1930s sets. you've usually got a 5 volt tapping for the rectifier, and the rest of the valves run on 6 volts. So let's just see if we've got that tap in. There we go. And yeah, that seems okay. That's about normal. But yeah, so as far as I can see, where do we say it was across there, weren't we? So we got, yeah, and our HT windings there as well. Basically the secondary high tension winding on the transformers there. So I'm reasonably happy that the transformer is not completely shorted out. That's one good thing. Right, what we could probably do at this point actually is I'll put those valves somewhere safe so they don't roll off the bench while we're playing about. Our output valve is a AC2 pen. It's a Mazda AC2 pen. That it's probably original as well by the look of it. Unfortunately, the rectifier valve hasn't got any markings left on it. They've been rubbed off over time, but I do have the trader sheet here which can tell us what that valve actually is, and that valve is a U12, which is quite a common rectifier valve of the time. So yeah, that should be okay. Right, what we will do, I will go and get the variac and a safety lamp, and we'll get all that connected up, and we can actually power the transformer up with the output valve and the rectifier valve out. We could leave the output valve in, to be honest, but I'll take it out because it just gives us some more pins just to check some of the voltages on. So I'll dig the variac out, and we'll come right back, and we will just power this transformer up just on the low tension side, just make sure we've got voltages on these pins, and then we'll take it a little bit further. So back in a sec. Right, okay, I've got the variac out, and we're not just going to plug the variac straight into the radio. What we're going to do, for one thing, we've just got 2 wires there, and we're not going to just shove them in the thing. I've got a safe block here. We'll plug that in. And we've also got a current limiting lamp here. This is basically just a 100-watt light bulb in a holder. If you've ever seen a lamp limiter, I've shown many years ago how to make one, and Shango uses one, and lots of other people that work on these vintage stuff use a lamp limiter. All I'm using it for here is just in case anything happens, that will just take the excess current. It's not 100% essential for what we're doing, because we're not trying to reform, and we're not basically doing anything with the high tension side of this at the moment. We are just working on the low tension side and just see if we can get the filaments to light up. So I will use it anyway. So essentially what we're going to do is we're going to connect that live connection to there like that. We'll connect neutral to that side there like that. Shut that down. That should be making a good connection. Obviously, this is one of these things that you do if you know what you're doing. We do have potentially live connections here exposed, but providing you don't touch that, again, we're quite safe, and we're not actually running at the moment the full mains voltage through it. That is our on switch, I believe, there. So we'll switch the variac on. We'll switch, which I think is the radio on. And basically it's just a case now over the next perhaps 20 or 30 minutes, just slowly bring in the voltage basically bringing the voltage up. And actually, I don't know if you will be able to make this out, but I've got 100 volts from the limiter there, sorry, from the variac going into the radio. The radio is actually set to the 250 volt tapping, and I can just see illumination on that dial bulb there. It's barely visible, you've just got the filament just starting to glow. So it does at least show that the transformer is working to some extent anyway, even at this point. We'll very slowly bring this up until we've got like 230, 240 volts on it. So what I'll do is I'll pause the video here, and I will slowly wind this up over the next, say, 20 minutes or so, and we'll come back when we've got a reasonable voltage on this thing. We've got a little bit of glow on that bulb, if you can see there. So that is taking a little bit of current. Not a huge amount, it's just a basic glow there. It's not pulling tons of current on it. It's actually much better if you've got a clear bulb to do this, but I'm actually really running out of clear filament bulbs, 100 watt clear filament bulbs. But I mean, this is, you know, if you shield it like that, you can just see a very dull glow on it. Bring that up another 10 volts, because every few minutes I'm just putting another 10 volts on it, and I'm just watching, make sure nothing nasty happens. Essentially, if that was to glow bright like that, we'd know something happened, sort of like a winding is shorted in the transformer or something like that, but that'll just protect everything else. So we'll be back once I've wound this up a bit, and we'll see what it's doing. So back very shortly. Right, okay, we're back. It's been about an hour, and I've just basically slowly increased the variac, and we're on around about 230, 240 volts here now. As you can see, the safety lamp is actually glowing reasonably brightly there, but I don't think that's a major issue actually, because if you think, we've got the filaments from those 3 valves there being powered. The filament obviously on the bulb, which is virtually nothing, that's being powered. What I'm going to do now, I'm going to shut off the... In fact, before I shut that off, let's just check, see what whether we've got a high tension HT voltage coming out of the transformer. So we switch on there, and we can just measure this on the base for the rectifier. I don't know if you can actually see that, so I'll just tell you what it's showing anyway. But if we go on this pin here, and we've got about 230 volts or so AC on that pin there, which means that the secondary on this transformer is actually producing HT, which is basically what we need to be able to get the radio to actually work. So I'll shut that off, get that out of the way. We'll turn the variac off, so this is now no power to it. I can actually touch the safely touch the radio. In fact, just to be on the safe side, just to make... sorry, just bear with me a second, folks. My phone's going. Sorry about that, folks. That was my mate Andy over at Vintage Electronics Repair. Anyway, right, what I'm saying. It's the only problem when your phone goes like that. It kind of throws you off where you was actually at in the video. Right, so where we got, we just checked and we've just seen that we've got HT being produced there. The next thing I want to do is just check. Now we've got it powered, that's what I was doing, I was just showing you. We've got it switched off on the variac, but we will also just open that like that. So we're absolutely sure that there's no power on this chassis before we actually touch it. And what I want to do first is basically just check the transformer and see how warm that transformer is getting, and that is just lukewarm. There is a little bit of heat in there, but nothing, you know, it's not burning hot, it's not even hot, it's just lightly warm. None of that wax that's been dribbled has gone soft. Let's try on the other side as well. But all that wax is that has actually leaked there, it's still nice and hard. So I'm not too concerned that we've actually got anything majorly wrong with that transformer. That's a good thing. Right, next thing we're going to do is we'll flip the chassis over. We'll get this disconnected for the time being, just to make life a little bit easier to work on. We'll get that shut down and that out of the way. So we'll unplug that from there and get them nice and out of the way like that, which is safer. We'll bring the chassis back in and we will... Ooh, this is a heavy chassis as well. Let's get it up on this end like that. And I'll try and get you so you can actually see what we're looking at here. Let's see if we can get you zoomed in a little bit. Ooh, that's the wrong way. There we go. Right. So we've got the main switch down there. It's a very, very strange main switch on this, but it seems to work alright. I'll just take you a quick tour around. So that's our choke there. We've got a linear choke, so that's basically just like half a transformer. It's just one winding. It's just there to basically smooth out any ripples in the DC once it's been rectified to the AC has been rectified to DC. There's two things I want to check here before I'm going to attempt to actually power this radio up. The first one is these two capacitors. There's one there and there's one there. Now these two capacitors are the wet electrolytics that smooth the HT once it comes off the rectifier valve. And I'm not bothered if they're open circuit. I'm not bothered if this radio hums at this moment. It's got a terrible hum when we actually get it to play. But what I don't want to do is try and power the radio up if one of those two capacitors is short circuit. Because basically we're putting a short on the rectifier valve and we could ruin the U12 rectifier valve doing that. So first thing I want to do, we'll set this to a ohms range on the meter. So this is not really testing us whether these capacitors are good or not. All we want to know at this moment is, are they short circuited or not? So we'll get a good ground. In fact, we can actually probably use, well, in fact they use the chassis of the radio as the ground. They're a grounded can, so if we can get a good ground on the chassis like down there, and then we will go onto the each capacitor. Just make sure we have got we're working there. We've got absolutely no reading there at all, which means that that capacitor is either open circuit or that capacitor is still okay. Now the fact that it's not climbing at all will make me think that that capacitor is completely and utterly open circuit. So we're not to, we'll even go straight across the capacitor like that, and we're getting absolutely no deviation on the meter at all. And if you can see the I'll hold it up like that so you can actually see the meter as well, but when I go across that capacitor, as you can see, there's absolutely no movement on the needle at all. So that is, like I say, it's either open circuit or it's okay. If it was okay, I'd actually expect to see the it slowly rise up like that. So I'm thinking that's probably just open circuit, which, like I said, doesn't matter for the moment for what we're doing with the radio right now. Let's test this other one. Again, we'll get a good ground. We'll go onto there on the capacitor. And again, I'm not getting anything at all. I can even go right onto the capacitor can up there. And again, we're getting absolutely nothing on that capacitor. That capacitor is most likely just completely open circuit. Now there's one more capacitor which I'm interested in before we even try and power this radio up, and that is, I think it's that capacitor in there, but I'm going to just double check on the trader sheet I've got here, and that is the bypass capacitor for the output valve. Again, if that capacitor is faulty, it will put voltage onto the grid of the basically put a DC voltage onto the grid of the output valve, which can damage the output valve, or more importantly, it can damage the output transformer. So let us just double check that it is indeed that capacitor there that we're interested in. So if we have a look at the capacitors that this uses, let me just see where it is on this sheet. Condensers here, and we are looking for which is V1. Is V1 our output valve? Or is V4 our output valve? Let's just find out which the output valve is. The output valve is V4. So basically we're looking at the decoupling for V4 on here. AF decoupling to V4, 0.1 UF, and it's capacitor C20. So we can have a look at the basically little diagram here. It's not on the top of the chassis, I don't believe. Let's carry on. We've got an underview of the chassis here, and if we look along and up there, we've got R23, which is that variable resistor there, and right next to it we have C20, which is indeed that capacitor down there. That is one capacitor. Like I said, if that is leaky, it can potentially damage something. So we really do want to either change that, or if we don't want to change, I think it's a 0.1 UF. Not that it would really matter too much on the moment for what we put in there, providing it's just actually preventing that DC getting across. So yeah, that will work fine. What I will do, I will just find a 0.1 UF capacitor, and we will I don't know if we're going to replace it, or we'll just tack in a capacitor to replace that one capacitor there, and then we'll actually look at seeing if we can perhaps power this thing up and see what it does. So I'll find that capacitor and we'll be right back. Right, okay, well the iron's warmed up, and I've got a replacement 0.1 UF capacitor here, which will do. It's a 630 volt rated part, that I think, so it should be absolutely fine for this. We'll get that old capacitor out of there. Yeah. Grab a suitable screwdriver. There we go, that should do. We'll go in there. Take that screw out. We should be able to ease the capacitor out. I can take the clip off. Let's see if this will come out. This has actually got really long wires on it. Got connection there, and the other one goes up to that volume control there, or tone control I think it is actually. And then the other one goes along to the output valve there. Right. What I think we'll do, we'll just desolder that if we can. Let's see if that's going to come off. There we go. There we go, that's off. We can see where that connects to. So we've got one side there, and the other one, it connects to that variable resistor there. So we'll disconnect that, and what we'll do, a new capacitor, we'll actually just connect it from that basically tag strip up there and then we'll connect that wire onto the other side of it. I mean, we may come in and redo that if indeed this radio is going to be fully restored, but for testing purposes that will be absolutely fine. So let's get that off there. There we go. Let's have a quick look at the old capacitor we've pulled out. Now I think that might actually have been replaced once in the past anyway, because that's got a date code of 1942 on it, and this radio is from 1934. So it does look like someone has been in here in the past and actually changed that out. But even so, you know, that was changed out a very, very long time ago. So, right, working volts on that is 300 volts DC, so 630 volts DC part will be absolutely fine as a replacement. We'll take that out of harm's way. We'll get this new capacitor installed, bend that leg out. And what I'm going to try and do is just feed that in fact, I don't think I've been left a hole there. Clean that off a little bit. Just turn that slightly. There we go. Not soldered in place yet, we've just got that through the actual hole. Bend that round. We don't want to have that shorting on anything. We'll just solder that in place. Like I said, this will get done again. This is just for testing purposes. And we'll tack that capacitor in place like that. Yeah, I'm happy with that. Bend that out. We don't want that to short on anything else, and we can just J-hook the new wire onto the old wire there. Twist that on like that. And we'll just solder that in place. This won't be left like this. This is just for us initially testing this radio. There we go. That will do. In fact, we can just snip that bit of excess wire off there, and that should be fine. That's the audio bypass capacitor on the output valve replaced. We'll keep hold of that little clip and that screw, because we may want to put the, if we do fully restore this radio, we may actually want to put that back and put a new capacitor underneath there. But like I said, that will do for the initial moment for testing. Right, I'll switch my meter off for the moment and get that out of the way. We'll get the soldering iron out of the way. That can go and live on top of the variac up there for a moment. Right, now what we can't do at the moment is just put power up this thing, because basically nothing will really happen. We've got a couple of options here. Well, basically, what we can do is we can put the rectifier and the output valve back in. That's the rectifier back in. And that's our output valve. And those are in. Now we've got two options here now. We can either go and get the original speaker and field coil out of the cabinet, because this uses basically a mains energized speaker. So it doesn't have a permanent magnet on the speaker. So essentially what we can do, we can either get that and connect that up and connect the field coil and everything up, or for testing purposes we can use a like a standard speaker and basically bypass the field coil, and that will work for initial testing. It means I can just use a little test speaker rather than having to drag the cabinet out and set the cabinet up on one side and connect everything up with crock leads. It also eliminates, you know, a dead set from the fact we could have a faulty speaker or an open circuit field coil. Yeah, both are two things we can easily get round in the future if that turns to be the problem. But for the moment, it'd be nice to you know, not do that and eliminate that. So what I'll do, I'll just get the bits together. We're going to need to actually just connect a normal speaker up to this thing. I'll grab some wire so we can lash an aerial up. And we will power this thing up again on the Variac and actually see if we can get any audio out of it at all. So back in a sec. Right, okay, we're back. I've got it all basically connected up. I've got a bit of wire connected to the aerial socket, and I've got a test speaker here just hooked up to the output transformer with some crock leads. It's basically easier than trying to find the plugs and everything to plug it in through the back, and again it eliminates things that could be an issue which we can sort when we actually start restoring this thing properly. So we've just come straight off the output transformer there. I've got the you can't see it because it will be slightly off camera unfortunately, but down here, as we had before, we've got the safe block, we've got the safety lamp, well, the current limiting lamp. That's just going to be slightly off shot. I just thought I'd show you the actual radio itself. And that's basically it. So we'll switch the Variac on. I've got the Variac cranked right down again. So we'll switch the Variac on. And hopefully we're going to start seeing some sign of life. I'm not seeing any filament activity on that bulb just yet. So we've got that switched off or on. I think when I turn that, I think that's on. Again, I'm not actually 100% sure whether the main switch is actually okay on this thing. That could be. But let's see, let's just try bringing the voltage up a little bit and see if we get any activity on the now I've took it up to 100 volts, and yeah, I can just see the filament starting to glow there. You can barely see it. I don't even think the camera will be able to pick that up, but we have got a tiny little bit of illumination on the filament there, and there's a tiny little bit of illumination on the safety bulb, on the current limiting bulb. I can't actually get that up into shot unfortunately, but it is just starting to glow. Well, obviously I don't think we'll have anything making any noise yet on the actual on the radio with too low a HT yet. Again, we'll just bring this up. So we're at about 150 volts there. I can't see any sign of any activity on the rectifier or the output valve there, but we do have a very faint glow on that dial light bulb. And no crackler or anything yet from the speaker. But we are, so like I said, we are at a very low HT at the moment. And we'll slowly bring that up. The dial, the safety lamp is glowing reasonably bright now, but bear in mind we do have the rectifier and the output valve in there as well. So far I can't see any smoke, I can't smell anything. That's one of the main things when you're doing this. You have to use all your senses. Your eyes, your ears, you're hearing for snaps, you're hearing for crackles. Your nose, you're smelling for things getting hot, things starting to burn. Like I said, so far we've not got any that is off. Right, so we're definitely on with that there. Let me just see if I've got any HT on the actual output transformer. We'll bring the meter in again. I don't know if you can actually see it. Where can I put this meter where you can see it as well? I wonder if I could be a bit naughty and we'll put that on 600 volts. Well, in fact, we want it on DC now, don't we? Because we're working on DC now. So switch that over to 300 and up. I don't think we're going to be quite up to 300. And put the meter up there, so hopefully you can see it as well. Get you up a little bit so you can see the meter. Hopefully you'll be able to see that. Ground 1 probe, and we will go onto the output transformer and see if we've got any signs of life. Nothing there, nothing there. So we've got absolutely nothing at all on the output transformer. Nothing at all. So we could have an outer, we could have an open circuit resistor. We've definitely got some reason that we're not getting HT to the output transformer, and obviously without the output transformer we're not going to get any form of prattle or buzz or anything at all out of this thing. It could be that we need that field coil. I don't think so. I had a look at the circuit and I don't think it would matter too much if the field coil was in or out of circuit actually. Let's just see if we've got some HT up here. I'll switch that back on to 300 and up on the DC. Let me get you down a bit so you can see the meter. There you go. Hopefully you can see what's happening on that. And basically what I'm going to do is I'm just going to check where the field coil connects here and see if we've got any voltage there. And absolutely nothing. Nothing there at all. So it looks like we haven't got any HT. What I will do, I will get the radio flipped over and we'll have a quick look on the bottom of the actual output valve. It could be that we've just got, it could just be as simple as a bad connection on the output valve, but I don't think so. So we're getting absolutely no sign of life there at all. Just quickly check on there again. Now we appear to be not producing any HT at all. So I will, I'll just quickly pause the video. We'll get this radio flipped up and we'll do a few tests around the rectifier valve and see if we're actually producing any HT. So back in a sec. Right, okay, I've got the radio basically flipped up on its side. We'll repower it. And we'll let that warm up for a minute. Got a little bit of a glow on the... I've not got it at full HT, I've got it at about 160 volts AC going into it at the moment. So we do have illumination on the dial light. What I want to do, we'll get a good ground point, good ground on the chassis, and what I want to do is basically probe on these capacitors here and see if we've got any HT being produced, because those are coming straight off the rectifier. So if I go on there, and we've got, if you look on the meter, it should be registering some voltage on there. We've got absolutely nothing at all. Now I don't think it's, well, we know that them capacitors aren't dead short because we've already tested that. So it looks like we've basically that rectifier is no good. We look on the if we look on the rectifier, that's the output from the rectifier there. That should be the DC coming off it, and there's nothing coming off there at all. Now if I switch over onto an AC setting on the tester, and we test the AC going into the rectifier, that one there, we've got about 180 volts AC going into the rectifier, but we've got absolutely no DC voltage coming out of the rectifier, which would indicate to me, unfortunately, that the rectifier is no good. Now what we can do, actually, for a quick test, just to see if that is the case and whether we can get the radio just to quickly play, is I'm going to go and get a couple of big beefy diodes, and basically we're going to sub out that rectifier, that valve rectifier, for something solid state, just basically just as a quick test, just to see if we can get HT to the rest of the set, and basically get the radio to play. So I will get the bits together I need to do that, and then we'll be right back. So back in a sec. Okay, we're back, and I apologise about that. Unfortunately, my camera crashed. I didn't actually notice it straight away, but hopefully you've not lost too much. And unfortunately, I think we've got bad news with this. I've been working away, and like I said, I just suddenly realised that the camera had actually stopped recording. It had just frozen. But I'm going back to my original thing. I think we have got a bad mains transformer on it, unfortunately. I've actually got a replacement output rectifier valve there. It's not exactly the same valve, but it is pin compatible. And just to confirm, I could see if I could get any HT through it. I don't know where this actually cut off until I started editing it, so I'm not sure how much you've actually lost. But basically, we was trying to get HT through to the rectifier valve, and we couldn't do. We've got HT coming off the mains transformer at AC, but we couldn't get the rectifier to do anything with it. And it looks like there's no filament supply to the rectifier. And unfortunately, it also looks like we've got no filament supply basically to the other valves in the radio. Or at least not what we should have. Now, I did say I was going to just use an analog meter for this, but just to confirm what I was seeing on the analog meter, I did actually dig out a digital meter. I'll just stick that there for you, and then we'll set this to AC. So we're on 200 volts AC. We're only measuring a filament voltage here, so it should be 4 volts. I've got the variac turned up to about 230 volts, but we do still have the lamp limiter in circuit, which will pull a little bit of voltage down. But another thing, the lamp limiter, I don't like how bright that is. Being that we're basically just running, supposedly just running the filaments for the radio. It should not be that bright. Another mistake, I assumed that this had like 4 or 5 volt filaments for the rectifier, and the others would probably be like 6 volts. Actually no, this radio is, like I say, it's a 1934 set. They're actually all 4 volt valves. Not that that's a problem at all, but we do need to make sure we've actually got 4 volts getting to the filaments on each of the valves, and this is where we've got a problem. If you look on the, hopefully you can read the meter down there, but basically if I go across the filament for the rectifier, so that's that pin and that pin, we've got 1.1 volts there. Again, if I go across the filament for the output valve, and get it there. Again, we've got about a volt there, 1 volt. If I go across the actual dial lamp, again, we've got about a volt there. Now we should have, even with the lamp limiter in series, we should be seeing, you know, 3.5 volts, something like that on that filament, and we're not. And unfortunately, I think the only thing, what I'm just going to quickly try and do, I'll just switch off the is I'm actually going to pull out all the valves, just in case we've got like a major heater cathode short or something like that, or a heater to ground short, something like that, in one of the valves, and that is actually causing that issue. I don't think it is. I actually think, I mean, it stays cool. It's not getting hot, but I think what we might actually have is shorted turns on the filament windings. I will pull basically all the valves. Well, it's not very well connected, but that shouldn't be a major problem. That's actually broke off there, but that's something we could easily fix if we can get the radio working. I'll just take I'm literally just taking these out so we can eliminate them from the problem. But I am got a horrible feeling. We've got a bad mains transformer. So that's all the valves out, and we'll connect it back up, and in fact what I'll do is I'll bring the lamp limiter where you can see it. There we go, it can sit up there like that, because you can see that now. And what we want to see is, does that light up as bright now? It's got no load on the transformer apart from that one little filament bulb there. So if I switch on, you see how bright that is? And literally all we've got in the set now is one filament bulb there, which, I mean, that's not going to cause, I'll turn that off, like I said, that doesn't cause any glow at all. So, unfortunately, it does look like the mains transformer there is indeed bad. I think we've got shorted turns on the filament windings. Now it should have basically separate filament windings for the rectifier and for the rest of the valves in the actual set. But looking at this, it's certainly looking like we've got a shorted turn in that transformer, unfortunately. Shorted winding on the heater windings, because we've disconnected everything. All we're really doing at the moment, because we've got the rectifier out, obviously we're not trying to rectify the AC into DC and power the rest of the radio, where, you know, we could have shorted capacitors or anything like that. That lamp should be barely lit. We've got basically 230, 240 volts on that, and it should just be a very dim glow. It should not be glowing nice and bright like that. I would have expected that to have got a lot hotter, the mains transformer. Now, here's the thing. If I switch that bulb out and connected this up, it might actually, you know, bring that filament voltage up, but at the same time what's going to happen is that transformer is going to start to cook. That is why we've got the wax dripping out of it. I did think when we first started playing about with this, we might have got away with it and it had just been running hot, because, like I said, it's a high hours set, or, you know, it's just a bad capacitor or something like that. I mean, it could even be the fact that a capacitor in the past has failed. It's been used like that. It's ran very hot, and that's what's actually caused the mains transformer to go bad. Another interesting thing is that if you look back at the first video I actually did on this, and what we found was basically the chassis wasn't connected to the cabinet. The screws were missing, and everything, like the speaker and everything, had actually been unplugged from the chassis. So someone has looked at this in the past, and I'm guessing they looked at it, they diagnosed it had a bad mains transformer, and just, you know, put it in the shed for a part set or something like that. So unfortunately, at this moment, I don't think we're going to be going any further with this radio. I'll get that switched off. There may be a possibility that I can find a suitable transformer to replace that with. It wouldn't be worth, with the amount of cabinet damage this radio has got, to actually go ahead and rewind that thing. It looks quite a complex transformer. I am sure that the windings that we're after are probably buried on the inside, so it's not just a case of taking one winding off and rewinding a new one on. Though I might see if I can do something. I don't know. I suppose it's a possibility if I can identify which of the windings is the winding for the filaments. I'd have to put two on though if both have failed. I could possibly just rewind that part of the transformer if it's possible to access that part of the transformer. I don't really like leaving it on a downer like this, but I think that's where we're at for the moment. Is I said that transformer. The thing is, it just doesn't get mad hot, but you can see definitely by the amount. Let me get you zoomed in there so perhaps you can see how bad this wax is. Get you bent over there. This is what we're talking about here. Can you see all the wax down here, which is basically spilled out of the transformer? You can see it here as well. It's actually fused a few of the wires into place, but there's been a lot of wax over time basically run out of that transformer. It's all run down here. It's down that side as well there. There's a little bit on the other side of the transformer, but nowhere near as much. It was mostly around here. But like I said, that's where your rectifier valve is, which is running warm, which is going to cause that a little bit. But yeah, I think that's where we're at the moment. I also believe that those capacitors there may have been changed in the past. I don't think those are actually the originals. I think it should have had, judging by the service sheet here, it should have had a square can kind of capacitor there. With 3 capacitors in it, and what we've got instead is we've got 2 of them capacitors there, and then there's actually, if you look at that, let me get you down, if you look at that nub down there, that is another capacitor, and you can actually see where there is other holes where a capacitor has been there in the past. So this has had work done on it in the past, and I mean, when I say in the past, I do mean a long time ago. These possibly 1940s or something. Well, do you see that capacitor I took out? I had a date code on it. Yeah, that is 442. So, like I said, I have a feeling this was probably repaired in the 1940s. Possibly when those capacitors were fitted as well. Can't see a date on them actually from when they definitely don't look original though for the rest of the set. Feb 52, there we go. If you look there, there's actually a date on that. That's February 1952. So this has definitely had work done on it in the distant past, and like I said, I have a feeling that unfortunately that is the culprit. I'm not going to scrap the set just yet or anything. I will see if I can. I'll have a look through all my junk and see if I've got a suitable 4-volt transformer we could try in here. And if not, I might in the future, like I said, have a look at seeing whether we can possibly rewind the filament windings on there. I'm pretty certain the shorted windings, it's not open circuit, because we get continuity through it and we're getting a volt off it. But like I said, I think there's basically shorted turns on them heater windings, and that's what's caused the problem. And that's basically probably what put this radio out of service in the first place. Anyway, I'm going to leave it there for now. Like I said, I'm ashamed to end on a little bit of a downer with this radio, but it may come back to see another video or two, depending on what I decide to do with that. So I hope you enjoyed watching this me tinker around with this thing. I apologise for the camera kind of crapping out halfway through, and you might have missed a little bit, and I won't unfortunately know that until I put this in the computer and try and edit it up. So I will say thanks for watching for now, and goodbye.